we're taking an exciting journey into the past of our universe. If we know the universe is currently expanding, we can imagine rewinding the film to a time when the universe was more compact and, therefore, hotter. So if the universe had a beginning and expanded from a very small volume, it must have been extremely dense and hot in its early stages. In this dense and hot early universe, photons couldn't move freely. But as the universe expanded and cooled, photons began to move freely. This period is known as the last scattering surface, which occurred when the universe was about 380,000 years old. Shortly after the Big Bang, the universe expanded at an incredible rate. This rapid expansion is known as cosmic inflation, where the universe grew 1078 times larger in less than a second. During this period, the universe had almost uniform energy density everywhere. However, it was also extremely hot. About 1 second after the Big Bang, the temperature of the universe was around 10 to 32 Kelvin, and its density was incredible. As the universe expanded and cooled, matter-antimatter pairs could no longer form, and those that did quickly annihilated each other. This process resulted in a slight excess of matter, which is why we see more matter than antimatter in the universe today. When temperatures were high, forming atoms was difficult because the universe was still extremely energetic, and electrons were easily knocked away from nuclei. Thus, the universe was in a plasma state shortly after the Big Bang. During this time, photons had difficulty moving freely. Through processes known as Thomson and Compton scattering, photons constantly collided with atoms or electrons. The universe, therefore, appeared almost completely open. From within, one could only see a few light years away, which is quite limited on a cosmic scale. However, as temperatures dropped, nuclear fusion became possible just 3-4 minutes after the Big Bang. Protons and neutrons combined to form heavier elements, electrons joined atoms, and photons could move more freely. At this point, about 379,000 years had passed since the Big Bang, and temperatures had dropped to around 3,000 Kelvin. This process happened simultaneously across the entire universe. As this occurred, photons could move freely in every direction, making the universe transparent. The cosmic microwave background radiation we see today is the leftover energy from this era, spread throughout space-time. That's it. I hope you enjoyed this exciting journey into the universe's past. For more fascinating space and science content, don't forget to subscribe to our channel and like this video. See you next time.